Alright, Mr. Kaysen is going to step you through going into jogging in world mode. Now again, we'll zoom in on the pin in a moment, and he's going to be pressing the coordinate button, and you'll see this joint word up here change to world mode. So if you want to hit the coordinates, Mr. Kaysen, so we can see it do that. And notice there's different things, jog frame and now world. So we're in world mode, and we're basically going to be pressing the same keys that we did, but we're going to see some differences in the movement of the robot. So as Mr. Kaysen presses those buttons, I'm going to zoom out on the robot again so you can kind of see it. And he'll be pressing the buttons for the different axes that he talked about before, and he'll talk about those as he's going. You'll see some definite differences in the robot's behavior in world mode.
Okay, so in world mode, it moves along 3 axes. X, which is back to forward, Y, which is side to side, and Z, which is up and down. So I'm now going to jog X. The controls work exactly the same way as they did in the other, except now instead of controlling individual joints, it'll control all of them at once to make a final motion. So I'm going to go plus X now, and it's going to come straight forward at us. It's rotating all 6 joints at once to do this. And now Y. The easiest way you can tell about this is that the piece is never moving. If you look at the gripper, it never rotates, and it never moves in any direction other than the one you tell it. Okay, so now we're going to go to Z, which is up and down.
So this would be very handy if you're trying to pick up or place that object that's in the gripper in a specific point. Is that correct, Mr. Kaysen?
Yes.
Right.
And then these are just the Cartesian movements. Cartesian being along the X, Y, and the Z planes. However, we also have roll along each of those axes. So now we're going to roll along the X. It's going to rotate its point around there in order to line that X up. So like the piece itself, when doing this, is going to be moving like this. Okay, so I'm going to reset that going back to here. Then I will show you the Y movement. Y movement is going to move it like this. It's going to take the piece and rotate it forward towards you. However, you do have the issue of limits when you're doing this as well. Because like at about this point right here, it won't be able to go any further because all of your joints are straight forward and you can't connect back to that point. So now I'm going to go back on the Y and move back a bit to show you on the Z axis. The Z axis isn't going to be as noticeable in this one, so I'm also going to rotate the X so you can see it better. You should be right about right here. It'll rotate itself like it's screwing something in.
And some of these robots, and of course it'll be a much more faster, not more faster, but much faster motion. But some of these could actually be used to torque down an object. So that rotation could be used to torque a particular screw.
However, as mentioned earlier, these robots do have limits on its axes.
Right.
So you'd only want to use it like if you have less than a half a turn to go on something.
Right.
Like, so that you can make sure that you aren't going to run into any limits when you're doing it.
Very good.
And that is how you jog it through world mode, which is the Cartesian axes.
All right, it also asks us what is the current selected jog override speed in this particular lab. So what speed are we currently at on our pendant?
We are currently sitting at 30%.
All right, let me zoom in on that. We can see that, and this is, I have to make some adjustments here, but Mr. Cason's propping it so we can get a good view of it. So what is the fastest speed available?
Fastest speed available is 100. But you aren't going to be using that one way too much because this is as fast as it can go.
Right.
If
go ahead.
If you're using this, you do not want to be using 100 because you will overshoot anything you try to get to.
Right.
And you could make it hit too hard on a limit. And you might not
Absolutely.
be able to move it that well.
And you could damage our robot, which would be a bad thing. So, so we're going to show you that speed button he was using to change that right here on the pendant. So I'm going to zoom in on the pendant again. And you see down here you've got some plus and minus percent errors. And those are the ones that you press that actually changes that 30 that we just saw to 100. So I'm going to go back to that speed value. And what is our slowest speed? The book wants to know. We're currently at 100%.
By the way, whenever you're pressing this button, you can also hold shift.
Right.
When you hold shift, it'll go from, now I believe, for the lowest to the middle to the highest.
Right. So it's a quick way of doing it, and you see he just went from 100 to 50 to down to very fine.
Mm-hmm.
And this is a super fine. You can barely, I'll have to go back to the robots, you can barely, if it weren't for hearing the servo motors, you wouldn't even know there was motion going on hardly, because it's so hard to see this thing move in fine position, but it is actually moving. So we can go all the way down to fine. So we can be anywhere from fine, which is less than 1%, all the way up to 100%. And he talked about the speed change key when you're using the shift and when you're not. And
it has one below fine, really.
right.
It has very fine.
Now it says practice jogging the whirl frame with the pointer perpendicular to each side of the box or table to ensure that you can successfully move the pointer along the X, Y, and Z plane. So I'm going to insert a box in here, Mr. Casey. And if you want to open the gripper while I'm doing that, I'm going to give you a chance to illustrate that. And we'll just use a marker as our pointer.
So let's open the gripper. So menu 5, which is input, out, no, wait. Yeah, input, output.
I know we're probably blocking the camera. Right now, we'll get to the digital later. We're just going to open this gripper so we can have something to point with. And we're going to latch this marker in so you can see. Alright, so if you want to close that gripper.
Don't try this at home.
Right.
Because what we did there was actually a little bit, you weren't supposed to do it like that, but.
Well, we're not going to ask you to do that. We just want to illustrate that, and an instructor, is going to work with you on this.
Shall I open the marker?
So, no, we'll just leave it. We'll leave the nib as the pointer.
Okay.
So, we're going to illustrate that movement. I'm going to zoom out. I'm going to probably, while he's doing that, grab a different color cap so it'll be a little more contrasting.
Yes. As a side note, the tool center point is another value that is changed frequently with this, with every little tool you stick to the end. Our previous tool center point was actually more to about the X on here. So right now, the rotation is going to be a little bit off. You'll find that it's going to move about the middle point of the pin rather than the tip of the pin.
Good point. In fact, we can go back to that, Mr. Casey. I forgot about that. So we have that.
Well, let's go ahead and do this for now.
Okay.
And just to illustrate the differences.
All right, sure.
So right now you can see that it's moving about like the X on the pin.
And notice the end of the pin. Now, as he said, it's really more toward the middle. And when we add this other object, you'll see that. All right, go ahead.
Okay, so it wants us to trace the corners of that box. So let's point the pen straight down. Mr. Adney,
Yes,
did you check on the side to see if the X rotation's off? The Y rotation.
So you want it to be in line with the back of the box? Is that what you're shooting for?
I'm aiming for it to be like just pointing straight down.
It's got to go towards you just a hair.
Okay, so towards me, so that would be Y minus.
There we go. A little too much, about halfway. That's probably pretty close to perpendicular.
Okay, so now, because we're going to be tracing this box, we're going to lower the Z to get close to it. And then we aren't going to do any fine adjustments until we get to about the level of it, about right there. So then we're going to move the X towards it. We're going to lower our Z again, since we're right there. Do I have to go forward or back to be in line with the corner?
Let's see. Let's see.
That was the question, though. You're looking down that line.
Oh, you're pretty much there.
Okay. So now we're going to move the X and the Y axes to move around the face of that box. So let's move Y plus first. It's going to move towards the end. Note that not everything is perfectly aligned in this, so whenever you're making programs, you're going to have to adjust each of your points individually. So now we're going to move our X positive, or not.
Well, it actually reached the limit, so I put the box a little further, but you get the basic idea. I can back that box up a little bit.
Okay, only release the dead man. You never want to have the robot active whenever somebody's working in it.
So you can hear this, the servo motors are off because you don't get that annoying high-pitched whine that after you operate this thing a little bit, you won't even hear.
Okay, so now we're going to go back on the X-axis to move the robot back a little bit. There's a likely chance we're going to have to raise the Z-axis,
Definitely are. Yep.
because otherwise it'll bump into the piece. Z positive. Okay, so release the dead man. Move it back to the edge.
Good.
Shift, reset, X minus, Z minus. Let's drop my speed down so I can get a little bit closer. Which is with the speed buttons that were listed earlier.
Yep. And I'm going to change the angle a little bit because I want to be able to kind of be diagonal to our box here some so we can see the actual movements. So you see on Mr. Cason's got that on one corner of our box pretty much. And he's going to begin tracing that box for us.
Okay, so now we're going to go back on the Y-axis, which is going to send it down the side of the box. However, as I was saying earlier, the alignment is going to be off because nothing's ever perfect. Notice that the marker cap is actually going more onto the box now.
Right.
So whenever you're programming, you're going to want to just do a fine adjustment that will go between the points that you set. Now we're going to go back on the X, and that will bring us this way. And then we're going to go up on the Y, which will send us back to the first corner where we were at originally.
So this is in world mode, and I'm on, just for illustration purposes, when he's finished tracing this box, we're going to ask him to move back into joint mode. And it would be a lot harder to trace this box in joint mode, I think, than it would be in world mode. So just to let you see the difference in the movement of the robot again. So we've made a revolution around the box, haven't we?
Yes, we've
All right.
made one revolution around the box.
All right, so let's make a, let's change it to joint. They don't have to see that. They know what we're doing. And now I'll try to make that same movement with the robot.
So I know the first movement will have to be minus X, but it's going to go way off because it's not on a circle. Then we're going to have to do minus Y, minus Z.
Yeah. So it's going to be a, instead of a single motion movement, it's going to be a
minus Y.
continual touching of different coordinate points.
The robot knows what each of these already is.
Right. So just wanted you to see, we don't have to really trace the box, just wanted you to see what would happen if we changed from world, where we were tracing it fairly accurately earlier, to joint mode. So obviously a lot more difficult to accomplish that same task in joint mode. So I think that pretty well wraps up. Any further comments there, Mr. Casey?
None that I can think of.
All right, so that is this particular lab. We're complete, and we'll be doing the next lab in a separate video.